All right, so it says the product and quotient rule. This is notes for T25. If we go through each method, what we're going to do is use this example to prove the actual product and quotient rule. First, we're going to do the product rule. So it says find the derivative of y equals x times the quantity x squared plus 1. They want me to first, method 1 says to multiply, then use the power rule. So I'm going to take the function, which we know is y equals x times x squared plus 1, and we're going to multiply the x in. So x times x squared is x to the third power, plus x times 1 is x, or 1x, right? So now this is my new y. Therefore, y prime, the derivative of y, we're going to use the power rule. That's x to the third power. I need to bring my 3 down. So it's going to be 3x. Now to the old exponent minus 1. Remember, we're using the power rule. So that's 3x squared. Plus, I know x written by itself is to the first power. All right? So I bring the 1 down times x. Now to the power that it was, minus 1. That's to the 0 power. But remember when we talked about this last class period, we said anything raised to the 0 power, that's just 1. So that's basically 1 times 1 is going to be 1. So that's 3x squared plus 1. All right, so that's what y prime is equal to. So now they said, well, if I use method 2, which says I'm going to take the derivative of each, then multiply. Okay, so if I take the derivative of each, it's saying, well, I'm going to take the derivative of the x, then I'm going to take the derivative of the x squared plus 1. So it says, so if I call x the function 1, let's just call it f of x, and let's call x squared plus 1, let's call it the second function, g of x, and take the derivative separately. So I'm going to first start off with f of x equal x. If I take the derivative, f prime of x, I know I'm going to do the power rule, that's to the first power. Bring down the 1 as 1x to the 1 minus 1. We subtract 1 from the exponent. That's to the 0, but I know x to the 0 power is 1, so f prime of x is just 1. G of x is x squared plus 1, so g prime of x, if I take the derivative of each one, x squared, I'm going to bring the 2 down, so that's 2x to the 2 minus 1 is just 1, but I know if I don't have an exponent shown, it's understood to be an exponent of 1, plus the derivative of the constant. We know the derivative of all numbers, constants, is just 0. All right. So now that I have the derivative of, if I call f of x my first function, all right, because that was the first expression we got to. And then x squared plus 1, which we call in g of x, would be my second function. Then according to the rule, because they said then multiply, they're saying remember we said d over dx means the derivative in terms of x of, they have the function f and g being multiplied. See that? They're saying it should be equal to f, which is the function f of x, times g prime, which is g prime of x, the derivative of the g of x function, plus g, which is just the second function g, times the derivative of the first function, f of x. So what are they doing? They're taking the f function and multiplying it to the g prime function. So if I go back and look, the function f, if I did it the way, if I did it the correct way, basically I'm taking it and cross multiplying it to the derivative of g, the second function. See that? So that means that the derivative in terms of x of those two functions, f and g, in this case is going to be x times 2x. That's the function times the derivative of the second function. The first function, which we call f, times the derivative of the second function. So that's x times 2x plus, now we have to take the g function and multiply it to the derivative of the f function. So g function was the first one, the g function that's written under second here is supposed to be multiplied to f prime. So it's like I'm cross multiplying that one. So g was x squared plus 1. So since that's a binomial, I'm going to put that in parentheses. Then times f prime of x, which is just 1. So times 1. So then what am I left with? If I simplify that, I'm left with x times 2x. That's 2x squared. Then plus, the 1 is being multiplied to each one of those in the parentheses, so that's x squared plus 1. Then I see I have like terms, 2x squared plus x squared is 3x squared. So that's 3x squared plus 1. So I come up with the same thing we got when we did it using the first method. Now, I know y'all looking at this like, why we can't just always do it like the first method? Well, what's going to happen, you're going to have other problems where expanding these, meaning multiplying all of that, may be harder. So it's good to know the product rule because in some cases it's going to be easier.